Welcome to part 1 of getting information from the graph of a function. We're going to suppose that x sub 1 is less than x sub 2. That just means if you substitute a number in for the x's, the first one needs to be smaller than the second one. If f of x sub 1 is less than f of x sub 2, that's your range values. If the range for the first output is less than the second output, we say that the function is increasing from f sub 1 to f sub 2. If f of x sub 1 is greater than f of x sub 2, we say the function is decreasing from x sub 1 to x sub 2. Suppose x is near a. Now a is just another value along the number line, and the a would also be defined as an input or a domain value. The function value f of a is a local maximum value of f if f of a is greater than or equal to f of x, meaning when you substitute a in, it is the biggest possible range value as an output. F has a local max at x equals a when this happens. The function value f of a is a local minimum value of f if when you substitute a into the function, you get f of a is less than or equal to f of x. So f has a local min at x equals a. In example 1, we're asked to use the graph of each function to determine the intervals in which they are increasing and decreasing, state the domain and range, find all local maxima and minima. I'm just going to, off to the side here, list the intervals that we need to find. We need to find where the function is increasing, decreasing. Then we're asked to find the domain and range. So we'll list the domain and the range. And then finally, we're asked to find all the local maxima and minima. As long as you don't have a horizontal line at a high or a low point, your local maxima and minima will be an actual coordinate point, not an interval. And you have to determine that on your own based on the context of the question. Now let's take a look at the graph itself. We need to find out where the function is increasing. So I'm going to look at this graph from left to right. If the function is sloping downward from left to right, it is not part of an increasing interval. So anything to the left of -2 is decreasing. From -2 to 1, the function is actually sloping upwards. That is an increasing interval. So I will list -2 to 1 as the interval on which the function is increasing. Now I'm going to look at where the function decreases. The function decreases anywhere left of -2, because as I work from left to right, the function, the graphed curve, is moving downwards. So it is decreasing on the interval from -infinity to -2. There's a gap clearly from -2 to 1, so I'll put a union symbol because I know if I look at this next interval to the right of 1, I can see that the function again moves downward as I move from left to right on the domain. And so the last interval will be from 1 to infinity. Now if I look at the domain of my function, there are no holes on this piecewise function. So as I move along, or pretend I'm just walking along this function, there's no place where I have to jump a gap in the graph. So the domain is -infinity to +infinity. And the range is very similar. So what I'm going to do is I'm going to take this curve and I'm going to extend it upwards and to the left, and to the right I'm going to draw an extension of the graph moving downwards as I approach +infinity. And I can see that this curve will continue up toward +infinity and to the left, and to the right it will continue down toward negative infinity, which means the function will never reach a maximum or a minimum. This means that my range is from negative infinity to infinity as well. Now let's look for local maxima and local minima. It's the high and low point on the interesting part of the graph that has been given to you. So this low point down here, that would be your minima, and this relatively high point up here at 1, 2 is the local maxima. And your local minima is at the point -2, -1, 2, 3, 4, 5, 6, 7. -2, 7 is your local minima.